So we're gonna kick off. Okay. So thank you everybody for coming today. We've got Tianbo Ji. I hope I've pronounced your name right, Tianbo.
Yeah.
Who's going to present his transfer talk on the evaluation of machine reading comprehension, dialogue, and multimodal machine translation. So I would ask everybody to mute for the next 30 minutes because Tiambo's going to take about 30 minutes to do this, and then we'll have open questions for about 10 to 15 minutes from the public, and then I'll ask the public to leave after that, and then we should allow the examiners then to ask their questions. So we have all the examiners here, have we? Yvette, do we have the examiners here?
Yes, we do, yeah.
Okay, great, super. Okay, so Tianbo, take it away.
Okay, so thanks for everyone. And my topic today is evaluation of machine reading comprehension, dialogue, and multimodal machine translation. And this work is supervised by Dr. Yvette Graham and Professor Gareth Jones. And first, let's have a quick view of the content. First, I will introduce what is natural language processing and the evaluation of it. Second, I will talk about the 3 involved NLP tasks and their current evaluation methods. Then I would like to give 3 research questions, including the analysis of limitations of current evaluation methods, and then talk about how these questions could be answered. Finally, I will show the current research about experiment on one of the tasks called machine reading comprehension, as well as further investigation of the other 2 tasks. So, natural language processing is a subfield of linguistics, computer science, and artificial intelligence. It's a technology for computers to understand human language and perform a wide range of language-based tasks. Similar to other fields of engineering, the development of an NLP system is influenced by the evaluation methods applied to these tasks. And in the domain of NLP, machine translation is a task enabling computers to automatically translate text from one language to another. As one of the most widely researched topics, the evaluation methods of MT have been well developed and also significantly influenced the evaluation of the other NLP domains. And here are the 3 tasks we choose in this research. And the reason of choosing these tasks is that either tasks like MRC and MMT still directly use evaluation methods from other domains, such as machine translation, or the tasks like a dialogue system still do not have any efficient evaluation methods yet. Machine reading comprehension is a task that, given one or more relevant documents, a machine should be able to answer specific questions. It can test whether the machine could understand human language. It has 4 types. And first is called clause test. Clause test is commonly used in language exams. Some words are removed from the original text, and the machine is required to fill them by choosing from the candidates. And this is an example of multiple choice. As you can see, the machine should select the right answer to the question from the candidates according to the provided context. And third is span extraction. And it asks the machine to answer a question about the given document, but it requires that the answer must be one of the subsequents from the given documents. And just like span extraction, free answering also asks the machine to answer a question. However, the machine is required to generate the answer rather than extract from the given context. So here is the evaluation of MRC. First is currency and exact match. A currency is quite straightforward, and as its name, and it's often used in clause tests and multiple choice. And exact match is a variant of a currency. And F score can be calculated by recall and precision. And if we select one as its high parameters, then it becomes F1 score, which is often used together with exact match in span extraction. The blue and rouge are often used in free answering. And blue is a method of comparing the overlap between the model output and the reference answers, in which N means the n-gram. And the rouge is first proposed for text summarization, and it includes a large number of variants, in which rouge L is most useful one, where L means the longest common subsequence, and the rouge L could be calculated by the F-score with LCS. And next is a dialogue system. A dialogue system is a technology that human users can communicate with a machine through natural language. And it has two types, task-oriented and open domain. Task-oriented dialogue systems help a user to achieve a specific goal, such as navigation or booking, and generally it should be within a limited number of dialogue turns. And this image is an example of a hotel booking dialogue system. And unlike task-oriented dialogue, open domain dialogue systems is not for a specific goal, but aims to enable humans to be able to communicate with a machine like a real person. And as you can see from the image, the user is able to speak about any topic he wants. And actually, there are 4 types of evaluations in the dialogue system. First is called overlap rate. Then blue and rouge are employed to calculate the similarity between the model-generated response and the reference answers. And the meteor is a matrix which can also be calculated by precision and recall, but it uses some other extra knowledge. For example, exact token match, stemmer, and paragraphs. And the recall NLP is a variant of recall. For example, recall 10 at 1 means there will be 10 candidates in the dataset, and only 1 of them are correct, and the other 9 are incorrect. For the second type, called word embedding based evaluations, they are all based on word embedding, and the first 3 are all calculated by the cosine similarity of the feature vectors between the responses and references. But these 3 methods use different ways to select their own feature vector. And last one is called perplexity. It is a probability distribution over the enter sentence. And different from other methods, the less is the value of PL, the better is the model. And third one is called scoring stimulation. And this kind of evaluation is that these methods will build and train a neural network to stimulate how a real user will judge a dialogue system. And last one is called human evaluation. And for now, actually, there is no standard human evaluation method yet, so we just talk some of them. The first is called Dark Crowd, which is a toolkit that can provide website templates for dialogue system assessments on the crowdsourcing platform. And second one is called interactive human evaluation, which is a public website, and the real user can directly talk to a dialogue system and rate on it. And then it's the introduction of MMT. So multimodal machine translation is a task of translating a natural language description of an image or a video into another language. As the image shows, the input of MMT is a sentence with an image, where the sentence is a description of this image, and the output is a sentence on the target language. And MMT is a subfield of machine translation. An evaluation of MMT has 3 kinds. First is automatic evaluation. So the blue and the meteor are used to calculate the similarity between the output and the reference. And the word error rate and the translation error rates are all computed by the edit distance between the translations and the reference. But the difference is that the TER is able to handle multiple reference at a time. And second one is human evaluation methods. And the first post-editing evaluation is actually lets the human accessor to do the translation error rate. It also records the editing time and keyboard activities. Fluency and adequacy ranking is actually a quite old human evaluation. The human accessor is asked to give a score of the translated language between 1 and 5. And direct assessment is now the official means of ranking system at the Conference on Machine Translation. And its score ranges from 0 to 100. All these evaluation methods are based on crowdsourced platforms. And the final one is adversarial evaluation, which is a method that replaces the input image with a random image to check whether the output will change. So, so here is our research questions. First, within each domain of interest, how currently do automatic metrics measure system performance? As you can see, most of the tasks still uses automatic metrics, but automatic metrics usually have their own limitations. For example, rules have 5 hyperparameters, including 8 different choices of n-gram, 3 choices of individual scoring, 2 choices of summary score, and the usage of a step word and the usage of word stemming. In total, it will have 192 variants, which is really hard to select. And second is grid vectors and vector X drama. They just simply calculate the word vectors. For example, they will directly compare the similarity between the model-generated response and the references, which will ignore the diversity of dialogue. And evaluations like RNN and ADAM, they are highly task specific, and they need a lot of resource to train because they are neural network. And last one is adversarial evaluation. This method is for MMT, but it cannot rank the performance of a system, which means every good MMT model should always pass the adversarial evaluation, but not every model passed the evaluation means it's a good it's a good system. So second one is that what are the limitations and the disadvantage of the direct application of metrics from MT and other domains to entirely distinct tasks in the system development in each area? Ideally, a good evaluation method must have a relatively high correlation score with the performance of human judgment, and this is the arm of current task evaluations to achieve. But this could be quite tricky. Generally, one researcher proposed a new evaluation metric. They would like to calculate the correlation with human judgment to show how well the metrics works. But when it comes to the experiment of human judgment, it could be sort of tricky because the experiment is specific, and it could be, and the research is able to fine-tune to make the results seem to reach the level of the human. For example, in the ADAM, they just simply collect the results from and scoring them from 1 to 5 based on overall score. But like automatic metrics, their score range usually from 1 to 100. And also, directly apply evaluation metrics from other domains can ignore specific features of the current tasks. For example, if we use blue on MMT, then the influence of image are totally ignored. And if we employ the metrics like root on machine reading comprehension, then the influence of questions are totally ignored. So our third question is that, can more appropriate new methods of evaluation be designed that are feasible given limited time and resources? Besides automatic metrics, current human evaluation also has its own limitations. They are usually not easy to set up, and the human accessors need to be guided or trained. And the user behaviors and the result can be highly varied. For example, a user could be given different results by letting them do a same job twice. And not all the human results are trustworthy, especially on the crowdsourced platforming. And some other existing human evaluations have no quality controls like a dial crowd. So here is our hypothesis. We could adapt direct assessment for these NLP tasks. Since DA is the official method of WMP, we think it has a potential to be the evaluation methods for other tasks. So we designed one human evaluation method on the machine reading comprehension tasks. It is an adaptation of direct assessment, and it is based on the crowd source platform called Amazon Mechanic Turk. And 8 systems are involved, including 1 human model and 7 state-of-the-art MRC models. And the dataset we used is called narrative QA. And this experiment has 2 parts, adequacy and fluency. Adequacy is the degree to how adequately the candidate answers to the question as a reference does. And the fluency is a determination of whether the candidate is aware of the natural utterance. And here is our Amazon Mechanic Turk user interface. As you can see, first it starts with the instruction and the questions with their answers. Then is a slider. But the difference between adequacy and fluency is that the fluency is only show the system-generated answers without references. And in order to prevent bias, the experiment should follow these rules. That one worker is show only one question with the answers per screen, and the worker are not allowed to skip the current one or review and change their previous decisions. This is because that it has been found on the machine translation. If different translations in one single screen can potentially influence the score of each other. And we also applied quality control on the crowdsourced environments. And the reason of applying quality control is that the human accessors and their results can vary. If we let one human user to do the same job twice, their result could not be the same. And also, quality control is required to fill out the unreliable data provided by unreliable human accessors, especially on the crowdsourced platforms. And here is our quality control operations. And we have 3 different operations. First is repeat judgment. And second is mechanically degrade bad reference versions. And then we use the reference at the answers. We will talk in detail in further slides. So here is the instruction of the hits. In AMT, workers can be assigned a human intelligence tasks. We will call it a hit. Both kind of hit will contain 100 questions with answers. As you can see, we have 10 system generate answers with 10 bad reference version, 10 answers with 10 exact repeat version, and 10 system answers with reference as answers version. And we also have 40 answers, so make up of 100 answers. And here is the detail of quality control. First, it's called repeat answers. We just simply copy the system-generated answers with its original question and references, which means these 2 are exactly the same. And second one is called reference answers, which means we replace the system-generated answers with its references. So for the worker, the reference and the answers, they look like will be the same, and we expect them to give us a score like 100. And the third is a bad reference. We just replace a random subsequence from the original answers by another sequence, and following these rules. And next is the dataset we use. The dataset we use is called a narrative QA reading comprehension challenge. It is proposed to solve the problem that the questions from most existing MRC datasets can be simply answered by using their information from the given document, rather than true comprehending the whole documents. And this data set is proposed that a system will not be able to answer the question unless they can read and understand the whole document. And this data set has 445,000 of questions, and in their data sets, they have more than 10,000 data. And originally, the narrative QA has 2 references for one single question in the dataset. So we extract one of the references and build them as the output of a human model result, so that we could have a highly quality MRC model. And the other reference will act as a reference. And besides the human model, we also have 7 state-of-the-art MRC systems to generate the answers for evaluation. And they are 2 multi-attention baseline with different hyperparameters, and 2 common sense systems. And one of them is with default hyperparameters, and the other is trained by the fine-tuned hyperparameters. And we also include a heuristic system, an attention-guided answer distribution system, and one example system from an NLP course. And here is our result analysis. As the image shows, shows a number before and after quality control with the average time for both assessments. And here is our quality control mechanism. To check if the result can pass, we use p-value, reference, answer scores, and sequence checks. The p-value is calculated by the paired sample t-test, which is we extract the score of the bad reference ones and paired them with the expected ones. And if the p-value is less than the threshold, we will accept this result, or this result from this worker will be rejected. Second is the reference answer scores. As we talked before, for the reference answers part, the reference and the answers is exactly the same, and the score is expected to be near 100. So we just simply calculate the mean score of the references answers and check if it's larger than the 95. Every result that less than 95 will be rejected. And third one is a sequence check. We just for each worker, we just check if one specific score continuously appears more than 10 times at one time. If it happens, this worker will be rejected. And we also build a self-replication experiment. We run the adequacy experiment twice, and we calculate their score and then calculate the correlation between them. As you can see, our correlation is quite high, which means this experiment is highly self-correlated and it's repeatable. And here is a result of system scores. And this is a human score of the systems. And this score is a mean standardized z-score. This table is sorted by the z-score. And the uppercase n is a number of rated answers, where the lowercase n is a number of unique rated answers. And the underlying score is that, which means this cluster is significantly higher than the cluster here. And this means this cluster is significant than this one. And it's the same as fluency. And then is with human scores with automatic metrics. As you can see, there are some very interesting results that these two models actually get a very high human scores, but their blue scores is very, very low, which means the human score disagree with the automatic metrics. And we also calculate the correlation between metrics. You can see the correlation between blue and the human is very, very low. And even the correlation between rouge and blue is still low, which means not only the human score disagrees with automatic metrics, even the automatic metrics disagree with each other. And here is a system ranking based on different metrics. As you can see, the human system is always the first one, but one system could be dropped to a very low ranking based on the change of the matrix. And here is a significant test. The colored cells indicate that the score of the row I system are significant greater than those of the column J systems. And this is calculated by the unpaired two-sample well-Coulson test. And the colored cell is within the range of 0 to the 0.1. And the reason of the human evaluation disagree with automatic metric is that if the system generates very long answers, the automatic metrics will think it is the wrong answer, but human will think this is the correct one. For example, for this one, if the question is what is DCU, the reference is Dublin City University. If the answer is very, very long, and as you can see, the blue score and the rouge score is quite low, but the human will think this is correct because it already contains the useful information for this question. So here is our conclusion. We propose a new method of human evaluation for machine reading comprehension, and it's valid and repeatable with a very high correlation score. And no automatic metrics can reach the level of this evaluation according to correlation test. And the automatic metrics did not always agree with each other. In these automatic metrics, rouge air performs the best among all the automatic metrics, while the blue score, the performance of both kind of blue is very bad. And this methodology is efficient and easy to set up, and it's also very cost effective. And the assessment of each system is around $30, which is quite cheap. And for the further work, we would like to deploy the human evaluation on both dialogue system and multimodal machine translation. Here is our ideas. So for the dialogue system, we need a new quality control methods, and several dialogue systems should be able to evaluate it for one single experiment. And for the multimodal machine translation, the evaluation method must be able to evaluate the influence of the image on that. And both of these methods should be deployed on crowdsourced platform and should be cost effective and self-correlated. And here's the timeline. And as you can see, we have finished the deploying the direct assessment on MRC, and we are doing the developing the DA on dialogue and the multimodal MT. So here is it. So do you have any questions?
So I'll put these questions to the public if anybody wants to ask questions. Thank you very much, Tianbo. That was very good. Well done. So if there's any questions from the general public, I'll take them now.
Yeah.
Hi, can you hear me?
Yes, we can hear you, Lucia.
Hi, Tianbo.
Hi.
Thanks. That's very nice work. And I'm quite interested in the evaluation of multimodal MT models.
Yeah.
And I was just wondering, like, one problem that we had when you did the manual evaluation using DA, showing the image, was that in some cases you have some discrepancies between the visual content and the input, the source text.
Yeah.
And it's hard for the annotators to make their mind about whether the translation should agree with the text, the input text, or with the image. And this comes, in some cases, there's basically errors in the description, but in other cases, they're just interpretations, different interpretations of the image. So have you thought about how you would want to address this to change DA-based evaluation for multimodal MT?
So if you can, if I understand correctly, so do you mean how we deployed the data set on the evaluation of MMT?
Yeah, it's a very specific question that sometimes what the input description does, or even the reference, let's say maybe even the reference may have slight disagreements with the image. Say the image
okay.
The image shows someone wearing a burgundy t-shirt, and the description says it's a red t-shirt.
Okay.
Even the reference.
Yeah. For now, we our choice is that we should always trust the data set. So usually, for example, the data we use is on WMT, and their data sets has been tested on the human accessors. So we could think this image is correct. The description is always correct, and sometimes the reference could have multiple references.
Yeah. So would you show in the DA evaluation? Would you show the reference then, or the input, or both?
We could if we deployed on the adequacy, yes, we will show the references. But for the fluency one, we will not show the adequacy. Will not show the references.
Yeah, I mean, this is. I think you'll come across this issue. It's just a bit hard to tell the annotators to use the image, but then to say the text is correct. So I think this is. I don't know the answer. This is why I was asking you. But when you get to that point, if you want to discuss, let me know, and I'm happy to get to get involved.
Okay. Any other questions, please? Okay, so I'll do my usual thing. I'll count down from 5, unless anybody else has another question. 5, 4, 3, 2, 1. Okay, So if everybody's, if the public would like to leave now, okay, and then the examiners can start to ask questions. So I'll ask all the public to leave now. Thank you.